Have you ever just stopped and wondered what is actually going on inside the mind of an AI like ChatGPT? I mean, how does it actually string words together so perfectly? Well, today we are going under the hood. We're going to demystify the absolute engine of modern AI, the Transformer.
So here's the plan. We're going to start with what was basically the big bang moment for modern AI. Then we'll follow a single piece of data on its incredible journey through the machine. We'll see how it gets transformed. And finally, we'll understand how it all comes together to do what these things do best: predict the very next word. Our whole story really kicks off in 2017. That's when a research paper dropped from Google called Attention is All You Need. And look, this paper didn't just tweak some old ideas, it introduced a completely new way of thinking that basically set the entire field on a new course. And when I say it set things on a new course, I am not kidding. As of today, this one paper has been cited over 200,000 times. In the world of academic research, that number is just astronomical. It shows you just how fundamental this work became. It's literally the bedrock that all modern models like GPT are built on. So what's the secret sauce? What did this paper actually introduce that was so powerful it changed everything? Well, to figure that out, we're going to look at the whole system from a really specific, kind of fun point of view. Instead of trying to understand the entire massively complex system all at once, we're going to simplify things. We're just going to follow one single piece of information, a word, or what the machine calls a token, and track it as it travels all the way from the input right through to the final output. All right, let's get started. Our token's journey begins right here, in the input block. This is basically where the model takes the normal text we give it and gets it all prepped for processing. You can kind of think of it as the welcome desk for the AI. So before our token can really go anywhere, it's got to pass through three really crucial steps. First, the text gets broken up into these tokens. Then, each token is converted into a rich numerical format. And finally, the model adds some extra information about where that token is in the sentence. Let's dig into each of those. First up, tokenization. I mean, how do you even split up a sentence for a computer? You could do it word by word, but then your dictionary would be gigantic. Or you could do it by individual letters, but then you'd lose a ton of meaning. So these models use a super clever hybrid approach. They break words into common chunks of letters. It really gives them the best of both worlds, a vocabulary that's manageable but still captures what the words mean. Okay, next, that token gets turned into something called an embedding. And this is where the real magic starts. It gets converted into this dense list of numbers, let's say 768 of them. And you can think of each one of those numbers, each dimension, as the answer to a question about the word. Like, is this an animal? Is this an action? Is it a color? This vector captures the whole vibe, the semantic essence of the word. But hey, context isn't just about what a word means, it's also about where it is. The model absolutely has to know the order of words. So, a second vector, a positional embedding, is added on top. And this is so important. Without it, in a sentence like, the dog chased another dog, the model would have no way to tell the two dog tokens apart. Position is everything. All right, now that our token is all prepped and ready, it enters the heart of the machine, the transformer block. This is where our token is going to get enriched, contextualized, and just fundamentally transformed. Seriously, everything that's happened up to this point has just been preparation. What happens inside this block is what allows the model to build up a deep, nuanced understanding of language. This is where the real heavy lifting happens. And the core innovation in here is the attention mechanism. In the simplest terms, this lets every single token look at every other token in the sentence and basically calculate an attention score. It's the model's way of figuring out, okay, which other words around here are the most important for understanding what I mean right now? And this example just perfectly illustrates its power. In a long sentence like this one, how does the model know who smiled? It wasn't the students, it was the teacher. Attention allows the model to draw a direct line, a connection between smiled and teacher, even though they're really far apart. This ability to capture these long-range connections is its superpower. So after attention does its thing, what's next? Well, the token's vector gets fed into a neural network that temporarily makes it way bigger, 4 times the size, before shrinking it back down. You can almost think of this as the thinking step, where the model gets a much larger workspace to process all this new information and enrich its features. And get this, this simple-sounding step is where about 2/3 of the model's total parameters are actually stored. It's huge.
Of course, there are also some crucial support systems in here. Layer normalization is kind of like a volume control, just keeping the numbers from getting too wild. Skip connections are like express lanes on a highway, letting important info from the beginning just zoom ahead and stay fresh. And finally, dropout is like a fire drill during training. It randomly switches off some connections to force the network to build stronger, more independent pathways.
So this entire process, attention, the network, all the support stuff, that makes up one transformer block. But the model doesn't just do this once. Oh no, it stacks these blocks one right on top of the other. A huge model like GPT-3 repeats this whole cycle up to 96 times, deepening the token's understanding of context with every single layer it passes through. So after passing through all 96 of those layers, our token is now just incredibly rich with context. It's finally arrived at its last stop, the output block. This is where all of that intense processing gets turned into an actual prediction. Now, the model has its own vocabulary, right? A sort of internal dictionary of all the possible tokens it knows. And for a model like GPT-3, that vocabulary has over 50,000 unique tokens. The model's final job is to pick just one of these to be the next word. So how does it pick? Well, it takes the final transformed vector of our token and projects it into a new massive vector that has one slot for every single word in its vocabulary. Then, this amazing function called softmax comes in and turns all those raw numbers into a clean probability distribution. And the result looks something like this. If you give it the prompt, "the cat sat on the model now has a probability for every single possible next word. It might give an 80% chance to mat, a 10% chance to chair, and so on. It's not thinking, it's just predicting what's most likely, based on everything it's ever learned. Okay, so we followed our token on its wild journey. Now let's just zoom out for a second and really appreciate why this one architecture, the transformer, changed absolutely everything. It all really comes down to two major breakthroughs. First, that attention mechanism we talked so much about, it finally gave models a way to understand context over long distances like never before. Second, older models had to read a sentence word by word, in order. The transformer can look at every word at the same time, in parallel. And that was a massive speed up that made it possible to train on the insane amounts of data we have today. So context and speed. Together, those two things were the engine of the AI revolution. You know, the invention of the transformer gave machines this brand new, incredibly powerful way to pay attention to data. It unlocked the ability to understand language and context at a scale we had never even seen before. And that really leaves us with one final, pretty important question. Now that machines have this new power, what should we, as humans, be paying attention to next?